Let us look at derivatives of arcs. So let's say we are given a curve. Let's take a fixed point A. This can be anywhere. Let's take another point P and a point nearby P. So let's make it nearby. I can't make it too nearby because then details will not be very clear. Okay, now from P, let's draw a perpendicular to x-axis. Let's draw a perpendicular from Q. So this gives you the y value of P, and this gives you the y value of Q, and this gives you the x value of P, and this whole thing gives you the value of x for Q. Okay, now let's join PQ. See, you can't distinguish these two, so that is why I had kept it a little bit farther away. And let's draw a line parallel to the x-axis. So if this is x and this is the distance of Q from P in terms of x, that is delta x. And let's mark this point as L. So this is delta x and this is delta y. So this is the change in x, this is the change in y when we go from P to Q. Okay, now I think we have got the diagram in place. So we have a function y equal to f of x. We have a fixed point A. Now here S is equal to the arc length AP. PQ is the arc length PQ. So when we go from A to Q, what do we get? We get S plus delta S. PQ is the chord, that is the straight line joining P and Q. As Q goes to P, so if we take this Q closer and closer to P, what will happen? Delta X becomes or tends to become 0 or tends to 0. So we can write it as a limit statement. Limit as delta X approaches 0, the chord PQ divided by the arc length PQ is equal to 1. Triangle PLQ is a right angle triangle. So chord PQ square is the hypotenuse. So that is the square of that is equal to PL square plus QL square. Or we can say chord PQ square is equal to delta X square plus delta Y square. By dividing all the terms by delta X square, we get chord PQ square divided by delta X square is equal to delta X square divided by delta X square gives us 1 plus delta Y square divided by delta X square, which is equal to 1 plus delta Y by delta X square. We basically take this and multiply and divide it by the same quantity so that we are ending up multiplying it by 1. So here chord PQ square is being multiplied with the arc length PQ square, and delta X square is being multiplied with again the arc length PQ square. The right hand side remains the same. What's the advantage of doing something like this? What will happen is, you know that PQ arc square or arc PQ is equal to delta S. So we substitute that. So delta S by delta X square we get. And we carry this as it is. There is another advantage which will come in the next step. The right hand side remains the same. Now, as delta X goes to 0, what happens? Chord PQ square divided by arc length PQ square goes to 1. So it disappears here. And delta S by delta X becomes ds by dx. And delta Y by delta X becomes dy by dx. So we have, as delta x approaches 0, ds by dx square is equal to 1 plus dy by dx square, which can be written as ds by dx is equal to square root of 1 plus dy by dx square. So we have arrived at the derivative of the arc with respect to x. Similarly, we can show that ds by dy is equal to square root of 1 plus dx by dy square. So this is the derivative of the arc with respect to y. So we have arrived at both derivative of an arc with respect to x and y. So that is derivatives of arcs. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.